Welcome back in the series of C programming tutorial. In the last lecture, we have seen how to work with array, and we have worked on 1D array, and specifically few points regarding 1D array we have discussed. Like we have discussed its definition and how memory has been allocated and how we can access it and how we have done the initialization. So few points remaining that we have not discussed in the last video. So let us continue with that part. We'll see the purpose why we should use 1D array, okay, and we'll see the demonstration at the same time. What is the purpose and its memory management through the addressing as well, right? Okay, so let us see the first one. The first purpose of array, 1D, 2D, whatever. Right now we know only 1D array, so I'll talk about 1D array right now. It says that the first purpose, efficiency to manage multiple data items. It is very true. Okay, so suppose here if I just go back, yeah, look at this array. Here, how many values I have stored? Here I have stored total 10 values. Total 10 values. Now think, if you want to store these 10 values into 10 different, under 10 different name, started from num1 to num10. So still you can say I can easily remember, but what about instead of 10 values if you want to deal with the 100 values? Suppose 100 students in a classroom, right? Then you want to purchase the 100 items for certain thing and you have to calculate the bill. So you can remember, is it possible for you to remember all the item names or through item 1 to item 100? No. So we'll represent all these values of similar type for similar entity, okay, under a same name, right? So that is the first point I have highlighted here. It very much efficient, okay, to manage multiple data items. For an example, suppose marks, okay, marks of 10 subject. Then suppose you want to calculate age of 100 students, okay, some of the examples. So efficiency to manage multiple data items. Clear? I hope this purpose is clear. Second one, easy access using index, right? So again, let us just go back to the GDB compiler. Okay, easy access through the index, right? Okay, so let me show you. Suppose once I create an array, suppose I have that numbers, okay, and if I have an array here, okay, array, suppose only 5 numbers I want to do, so let me initialize. Okay, fine. So I've taken five numbers here for this array. Through the index I can easily access. Suppose I want to access the kth item. Okay, I want to access the kth item. So here k equal to suppose 2. So what I going to write? Simple, nums of 2 equal to whatever I want. I want to assign the value 30. So suppose you want to print, so for the kth value, right? So let us take a variable k and ask the user to enter the value for k. Okay, so give a message printf, okay, select an index to access the location, right? Got it? Okay, careful, while you're taking the index from the user, you have to use this check index is valid or not. So in our case here, suppose I am not knowing the size here, so I hope you remember what we have done earlier. Okay, so please do not forget to calculate the size again. So integer size is equal to size of, yeah, size of pass the array and size of pass the size of integer, because it is an integer array. So it will give me the size. So now check the index, the value of k, is it greater than equal to 0, and at the same time is k less than equal to size minus 1. If so, so now you can print the item is, so first pass k and then pass nums of k. Got it? So we can easily access through the index, and else just print here, enter a valid index. We can print between 0 and percentage d. So what will be percentage d? Our case size minus 1. Okay, so let's run and see this run. Okay, some issue. Oh, it's greater than equal to 0. Fine. Now run. Yeah. What is the issue? Expected curly brackets, int nouns, done. Curly brackets are there. In the main k is declared, I am just accessing this value here. I did not assign the value the size. Okay, comma is missing. See what, something else and something else it is saying. Comma is missing. It is identifying here, but fine. Now run. Okay, so it is asked me to enter the index to access the location. Suppose I've given here 8. So the 8th item is 8. 8th item is also 8. Okay, fine. Fine. Let's run it again. So run. Now suppose 8 is the highest. So suppose the 10th. So enter a valid index between 0 and 8. Okay, right. So you can see the second purpose. First purpose, a collection of items you can have against only one name. So for a programmer, it is very easy to use multiple values of same type of same entity. No need to use multiple names here. And through the index, okay, here you can see through the index you can access any particular item at any point of time if the index is within the given range. Okay, fine. Now third one is iterative processing. Okay, so to understand the iterative processing means what? Means one after another. Okay, one after another, iterative process. So for iterative process, we'll solve one problem, that is searching an item. Searching an item. Okay, let us do. So we'll use now a simple algorithm here for iterative processing, understanding of this linear search. Linear search. Okay, so let us just discuss here how we can build the linear search. Okay, okay, let me take out the pen. Yeah, fine. So assume that this is the array that we have. Okay, this is the array that we have here. The same array, 3, 4, 5, 6, 10, 12, 4, 7, 8. It is a iterative. Okay, one after another, iterative process. Okay, so I want to search a number. So the key will be given by the user, any key. Suppose it enters 10. So I have to tell the 10 is present and its index as well, right? So this is the index. Do not forget, index will start from 0, right? Okay, so what we can do, we can match all the numbers one by one. Simple, right? So we'll compare with this item. Is it the key value and the value at the given index is same? So for that, what we can use, relational equality operator. Relational equality operator. We'll compare the value of the key along with the each index value. Item is not matched, move to the next. Item is not matched, move to the next. Not matched, move to the next. Not matched, move to the next. Matched. So whenever it matched, we'll say the item is found and it will return, or it will print the index. Print the index, and immediately, I hope you remember the jump statement, we need to apply the break because we have found the item. No need to continue with the further comparison. This is a comparison, right? No need to do. Okay, so let's build this here. Fine. So another purpose, this is the purpose, we can use the index, right? So I have explained the second purpose here, first and second purpose. Now I am explaining the iterative processing. Okay, so now let me ask the user to enter an item for the search, or we can use the key printf, enter the key to be searched. Right, take a scanf. Okay, take a scanf, pass the address, of key variable. Fine. Okay, now we need to search one by one. So we'll take a loop, for loop, because I need an index 0, 1, 2, 3, all the index, right? So the best loop I always prefer the for loop. I less than, what is the size? So I need to shift the size. Where is size? Yeah, I need to shift this size outside of the loop. Okay, fine. So now it will go up to size, not including. So size, up to size, and it will increment the index by 1. I hope you understand the loop now with the array. And now next we need to compare. So compare, it is a condition. So how to write the condition? Using if statement, right? Okay, so now we are matching the condition. Is the given key is equal to the item at the index I? So if yes, what we need to do? We need to tell the index. So printf percentage d is found at index I, right? So first one is my key and second one is I. And if it is found, once we done the stuff, no need to check further, immediately we jump out from the for loop. Okay, so if it is not found, how can I inform if it is not found? Okay, so if it is not found means what? If it is not found, I need to use some flag over there. So let us take a flag. Okay, so bool flag equal to true initially. Okay, so if it is found, it will become false, and to use this true false, what we need to do, we need to use one header file. Do not forget std bool.h. Okay, fine. So this one is the flag variable. We'll take care our searching is over. Suppose our searching is over, so now item is not found, so flag will remain true. Okay, so here we can do, if our flag is remain true, what we can do, printf the given item, the key, that is percentage d, is not present, right? Key. Got it. So I've used a flag variable. We can also use the value of I, and we can compare with the size. Okay, so if I is the last item, then there will be the issue. So that's why flag is used here. So now let us run and see. Okay, it is asking for a key. So what are the values are there? Let me just check. So 6 is there. First let us see. So 6 is found at index 3, 0, 1, 2, 3. Got it? Okay. Run the code again. Now enter 100. You can see 100 is not there. So 100 is not present. Okay. So let's run it again. Suppose I give now 8. So 8 is found at index 8. Okay. So always test the border value as well. So run it again. And now 3. It is also found at index 3. Okay, you can check that here our use of break statement. You can print the value of I and check how many times your for loop actually executed, right? So here you can do this stuff, integer iteration number, okay, initially equal to 0, right? We done the declaration, and here you can see iteration sorry, iteration number plus plus. So every time I'm going inside the for loop, it will check how, it will update the count, it will print me later how many times my for loop get executed. So here let me just print this just to make you understand the iterative process. Percentage d iteration number. Okay, so we'll run it again, and if we give a number 8 now see how many times it is iterated. 9 times. You can see, sir, index is 8, so how many numbers? 1 2 3 4 5 6 7 8 9. So it is the last number. So see, the more time it is taken, 9 number of iterations here. So run it again. Suppose no number, I give 400, no number, so again it will execute it 9 times. Suppose I look for 3, it executed only once. This is done because of the break statement. Once the matching has been found, immediately we terminate the loop. Okay, so I hope you understand this purpose and the linear search. There is another better technique, binary search, but we'll see it after this video. Okay, next, random access. Yes, random access, we can access the values at any point of time by using the name of the array and by passing a particular index I, right? And this I should be greater than equal to 0, and then I should be less than size. Okay, now data organization. Yes, data is organized in linear fashion, so that's why 0 1 2 3. So let me show you now addressing concept so that you can understand data organization. Data organization is linear fashion. If we reach here, we can easily access the other part. So it will be +1 +2 +3 +4, like that. Okay, so let me show you the address. So yeah, just stop it here, and now print the addressing. We have the array, right, with the size, right? So I am taking the for loop again. I equal to 0, I less than up to size, and I plus plus. Okay, so it's time to see the address of the variable. How to print the address? So we can print the address using two ways. One, you can use %u, that is address or unsigned integer. So unsigned integer, you can use %u, right? And then we can print the value %d. Okay, and now print the address. How to print the address? We have nums of I. How to get the address? This is the way, address of nums. So it will print me the address, right? It will not print the value. So to print the value, write only the index and the array name. No need to use address of operator. Now you can see the address and see the memory organization. Okay, some issue. Get it? It says unsigned integer. Okay, I have used unsigned integer. It is saying that address is integer star. So we are not at the position right now discuss the what is integer star. So okay, instead of %u, you can use %p. We'll discuss the pointer later. Because in C programming, address are represented through the pointer. So separate topic, we'll discuss it later. Okay, for the time being, instead of %u, use %p, and now run the program. Now see. Okay, so that is the reason I've used %u, because now number get printed in hexadecimal format. Fine. Okay, see the gap between these two. Shall I go back to the %u? Okay, is that, can I use here? Just a minute. Lu, and if I just yeah, forget about the warning. Okay, forget about the warning. Just check the values here. You can see how the memories has been allocated. The first value is the address 984. Okay, the second value 4 is the address 988. So what is the difference between them? The difference between them is 4. Got it? Yeah, the third value is 992. So what is the difference? So the difference is 4. Difference is 4. Why 4? Because I hope you understand why it is 4. Because our array is type of integer. So integer take how much memory? 4 bytes. So how it is now stored? It is in a continuous memory block. Okay, we have 3, we have 4, we have 5, we have 6, we have 10, 12, 4, 7 and 8. What will be the address? Just for the time sake, you can use the last 3 digit 984. You can write now 88, 92, 96. Then we have 1000, so 0. Now 004, we have 008, 012, 016. Okay, so this is the organization of the data. Clear? Fine. So this purpose is also clear. Data is very organized, so you can easily access once you get the starting address. Okay, addressing is not over. We'll come to this point again in 2D array and with the pointer. Just for the time being, you can okay right now. Facilitate algorithm implementation. Yes, we have just implemented one linear search. Okay, so in the next video we're going to see another technique, binary search, but before that we need to understand how to sort an array. Okay, after that we left with the advantages. What are the advantages? Static allocation, because we need to come up with predetermined how much memory we required, so memory cannot increase later at the runtime. Simplified code, yes, the complete logic has been executed over a collection of numbers. It is not running on individual numbers. So compact code, and efficiency is very much efficient. Memory is allocated properly, no wastage of memory. In the examples you can control it, and algorithm is properly executed, iterative process, right? So very much beneficial if you learn to work with the array. In other languages they may known as list. Okay, so concepts is almost same. Okay, almost same. So please practice, practice, practice. In the next video, what are you going to see? We're going to see the sorting, and thereafter we'll come again with the searching. That is another technique, binary search. And after that we'll move to the 2D array, that is the matrix. Okay, I hope you like my content. Thank you. Give me a thumbs up, and also please comment, and share the content with your friends and subscribe my channel. It's a request. Thank you very much.